Good morning, students. So far in the sets, we have learnt about the definition and how to represent a given set. I mean the notation of the set. Today, we'll elaborate the topic of the representation of the sets. So to represent sets, we have two ways to represent. Number one is roster form or tabular form. Number second is set builder form or rule method. Let's talk about the roster form. Roster form, in this form we list all the members of the set within braces, that is curly brackets, and separate these by commas. For example, let's say set A for all odd natural numbers less than 10. In the roster form, it is written as A is equals to, in curly brackets, that is in braces, 1, 3, 5, 7 and 9. Remember, in roster form, every element of the set is listed only once. That means what? You cannot repeat the members more than once. The order in which the elements are listed is immaterial. That means what? It can be written in any order. That means 1, 2, 3 is written as 3, 2, 1 or 1, 3, 2. In any of the order, all orders can be taken for consideration. So that is, the order is immaterial. The second form is set builder form. Why the purpose of getting two methods came into the picture? For example, if I have to write the set of all natural numbers in the roster form, it is very tedious job. So for that, the second method, that is set builder form or the rule method, came. In this method, we write the characteristics property of the given set into the form of sentences. So in this form, we write a variable x representing any member of the set followed by the property satisfied by each member of the set. For example, the set A of all prime numbers less than 10 in the set builder form is written as A is equals to, in curly brackets, x, this is the symbol of such that x is a prime number less than 10. In place of this particular symbol, you can use the colon sign also, which also means the same, that is such that. So instead of writing less than 10 prime numbers starting with 2 in roster form, 3, 5, 7. It is less than 10, 2, 3, 5, 7. Instead of this, you can simply declare a variable representing a set of prime numbers which is less than 10. So x such that x is a prime number less than 10. In other way around, you can write it as A curly brackets x such that x is a prime number. Okay, x is a prime number and x is less than 10. This way also you can write. Moving forward to the types of sets, we have empty sets or null set. The meaning itself, the word itself gives out the meaning of the given word, that is empty set, which is also called as null set, represented by the Greek symbol phi. Empty set means what? If a set which has no members or no elements, that is called as null set or empty set. It is denoted by the symbol phi. For example, the set of all real numbers whose square is -1. So the definition of real number is that number whose square is not -1. Okay, so all real numbers whose square is -1 is the null set. The set of all rational numbers whose square is 2, which is also not possible, and the set of all those integers that are both even and odd. Is that possible? It's not possible. A set consisting of at least one element is called a non-empty set. At least one element. Okay, it's called as non-empty set. Empty set means what? The set consists of no elements, and non-empty set means at least one element. If it contains single element, that goes to Singleton set, or a set having only one member. Having only one element is called as singleton set. For example, 0 is a singleton set whose only member is 0. One more thing to remember, to mention here, the empty set is either represented by the symbol phi or simply within two curly braces. No elements to be written here. If you write 0 also, that is considered to be a member. Okay? So singleton set having only one element. Second is finite and infinite set. Finite means the number or the members in the given set are limited. An infinite set, the members are not limited here. A set which has finite members, number of elements, is called as finite set. Otherwise, it is called infinite set. For example, the set of all days in a week is a finite set, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. 7 days in a week, so it is countable, so it goes to finite set. Whereas all the integers from the negative to positive means minus infinity to plus infinity, it is what? Infinite set. Okay, and empty set is phi, which has no element, is a finite set. In a finite set, A is called empty or void or null set. Now cardinal number, it is represented by n of A. That means the members of elements. The number of elements in a finite set is represented by n of A, known as cardinal number. For example, A is equals to, say we have numbers, natural numbers less than 6. So 1, 2, 3, 4, 5, and less than 6 means till 5 only. So we'll here till 5, closing the set. So n of A is equals to 5. So this is basically used for finding total members of a given set. I mean the elements of a given set, which is a finite set. You cannot find the cardinal number of a infinite set. Next one is equal sets. Equal sets, two sets A and B are said to be equals, which is written as A equals to B if every element of A is in B and every element of B is in A. For example, if a set A equals to 1, 2, 3, and if B is equals to 3, 2, 1, so this is an equal set, A equals to B. Whereas in case of equivalent set, it is based on the cardinal numbers. Like for example, A equals to 1, 2, 3, and B is equals to A. B is written as A, B, C. So in this case, this is equivalent sets because n of A equals to n of B, whereas this is not considered as equivalent sets. So remember, all equal sets can be considered as equivalents, but all equivalents cannot be considered as equal sets. Subset. Let A and B be two sets. If every element of A is an element of B, then A is called a subset of B, and we write A subset B, A is subset of B, or B is subset of A, read as A is contained in B or B is contains in A. B contains in A. So B is called a superset of A, if this vice versa is valid here. Every set is a subset and a superset of itself. If A is not a subset of B, we write A not subset of B. The empty set is the subset of every set. If A is a set with cardinal number A equals to M, then the number of subset of A are 2 power M, and the number of proper subset of A are 2 power M minus 1. We'll see this particular thing with the help of some examples here. For example, A equals to 3, 4, then the subset of A are 5, 3, 4, 3, 4. Okay, so the given set A is considered as, let's take A as 3 and 4, then the subset of A is taken as 5, single number 3, or the 4, or combined 3 or 4. Then the cardinal number, that is A, is equals to 2, because we have here only 2 members. And number of subset of A equals to 2 power 2. As we said here, 2 power M, so M is equals to 2, so 2 power 2 will be 4 here. Also 3, that is a subset of the given set A, is a subset of 3, 4, and 2, 3 is not the subset of 3, 4. Okay, 2 and 3 is not the subset of 3 and 4. Power set. The set of all subsets of a given set A is called the power set of A and is denoted by P of A. For example, if A is given as 1, 2, 3, then the power set includes set of all subsets of given A. Okay, so all subsets of 1, 2, 3 will be, first will be obviously the empty one, that is 5. Then number 1, 2, 3, then 1, 2, 2, 3, 1, 3, and then 1, 2, 3. 1, 2, 2, 3, 1, 3, and 1, 2, 3. So these are all subsets of the given set. Will go into the power set. Clearly, if A has n elements, then its power set contains 2 power n. Okay, that is, if it has got 3 elements, so it should be having 2 power 3, that means 8 elements in the power sets. That's all from today's class. You will get some questions based on the given topic. Try solving that, and if you face problem, you can ask in your virtual classroom. Thank you.